laws, they have names. You honestly need to know all of these Boolean algebra laws. So this basically just says that if you take an A, you OR it with an A. This is basically the output will be an A. I will just make an example with 1. I'm just looking, and then maybe we can somewhere get the law names from there. And then here, if you OR, remember an A is a variable, right? So what is an OR? An OR is this gate, right? It's this basically the addition gate, right? So it says that if you OR A, A is a variable. A is like a variable is just a memory holder. Whatever you what yeah, it basically just creates memory for you. So like for example, if you say name, the name can be anything. It can be Larry, it can be Salfi, it can be Cosa. So this A is just a memory. So now let's say you want to, for A, you're going to use a 1, right? A 1 here, pretend that's a 1. And then you OR it with a 0, In an A gate, in an OR gate, sorry, 1 odd with a 0, the output will be 1, right? That's in an OR gate. So, but remember this A is just a variable. So we assigned A to this value of 1 here, right? So now let's delete the value of 1. Let's see what happens if we set this to a 0. 0, 0, the output will be 0. So this law, what is it saying to us? So this law is basically identity law. This law is basically just saying that whatever you OR with a 0, the output will be that thing, right? So whatever we ORed with a 0, this is the output, right? So A or A. So this is called the identity rule, right? So let's give it a name here. Guys, I'm not going to mention these law names again. Identity, right? So we know number 1 is identity. This one is identity, right? So it's called identity. So whatever is here will be in the output, right? Okay. So now identity law has got 2. It has an and 1 as well. Here's the and 1, right? So what does it say in there? It says to us that if we take A and then we end it with a 1, take A, we end it. So here we have A, right? And then we have a 1. The output will be that A. So let's say the value of A is 0 this time around, right? Maybe some of you still don't believe me, right? So 0 ended with a 1. What is the output? The output is 0. Remember, for an AND gate to work, both inputs, all the inputs must be high for the output to be high. If one of the inputs is low, the output will be low, right? That's how an AND gate works, right? So, but we are not done yet, sir. What if we change for this value of A, we assign it to a 1? What's going to happen? Let's change the color and see what's going to happen. Let's go for black. So if we say 1 here, right? 1, 1, the output will be 1, right? 1 ended with a 1, the output will be 1. So what is this thing saying? This identity law is just saying that if you end anything, it doesn't matter what you end in this with a 1, right? But yeah, this value here with a 1, the output will be this value. So do you guys agree? We ended with a 0, the output was a 0. We did a 1, the output was a 1. So it means A, the output will be A. So that's what the identity law says to us. So I'm gonna put it here. So this is number 4. Number 4, we know its identity. Identity. Okay. So now let's look at the next one. I think there's idempotent law. Okay. So for the idempotent law, we're still gonna be using 2. 2, it says to us, if we take A, A, then we OR it with an A, our output will be A, right? It's this one, it's number 5. And then another one, there should be an AND version. An AND version is this one, number 7. A ended with an A is equals to A. So let's check. Let's try to prove that. So for number 5, let's have an A. Yeah. Let's use this green. We're saying an A. So if this is a 1 and a 1, right? A or A, the output is A. So it means the output is 1. So we know this is true because this is how an OR gate works, right? 1 OR with a 1 gives us a 1. 0 OR with a 0 gives us a 0. You see? So if we change this to 0, 0, our output is 0. So what does it mean? It simply means that if this is an A, then we OR it with an A, the output will be an A. So if these two inputs are the same, the output will be one of the inputs. So that's what idempotent law is saying to us, right? So let's write the law name, idempotent. So idempotent is rule number 5. And then idempotent is this one as well, rule number 7. Oh, the other one is the annulment law. Okay. Okay, so now let's come here. If we have A ended with an A, the output will be that A. For example, if we have a 1 ended with a 1, the output will obviously be a 1. 1, 1, 1, 1. The output will be a 1, right? Then if this was a 0, 0, 0, the output will be a 0. So that we call the idempotent law, right? So the other law that we have is the annulment law. So annulment law, it's this one, number 2 and number 3. So A, if we take an A, then we OR it with a 1, the answer will be 1. A and with a 0, the answer will be 0. Okay, let's try to prove it. So let's say here we have a 1. We put it here. We have a 1 here. Then they are saying it doesn't matter the value of this A, right? The output is going to be 1. Let's see if they're telling us the truth, right? So let's start and make this A to be 0. This A is a 0. Good. 0 odd with a 1, the output is a 1. Okay. So let's see. A or 1, the output is a 1. Okay, this one and this one are the same. All right, let's see. 1 and 1, they're the same. Okay, they might be right for this one. Let's check the other combination. Let's change this 0 to a 1 and see what happens. If we're still gonna get this input to be the output, right? 1, 1 and 1, the output is still a 1. 1 or 1, the output is still a 1. 1 plus 1, basically, the output is still a 1, right? So it means this is true. It doesn't matter the value of this. So this is basically our A. It doesn't matter the value of this. Annulment law says if this input is odd with a 1, the output will be a 1. So this is the annulment law. Let's write it here. Sorry, annulment law. Annulment law. Now, it's this one, right? But it's number 2 and number 3 anyway. So let's check number 3 with the AND gate. It's saying that any value ended with a 0. Let's put the 0 here first. We just need to make sure that these people are correct, right? So we have a 0. The value of A can be a 1. 1 ended with a 0. We know the output will be 0, right? So it's correct. It means 0 as one of the inputs. 0 is the output, okay? Let's change this value of A. This value of A, let's change it to a 0. Let's change it to a 0. Let's see. If we change this to a 0, 0, 0, together, the output is a 0, right? This is an AND gate. 0 and 0 will give us a 0. So it means this is also correct. So now we have the rule names for this, right? The rule names for that. And then I already said the one that you know that you need to multiply out or use brackets, this one, it's always the distributive law, right? Distributive law. Distributive law. Distributive law. And then this one of 2 complements is basically the double negation law, right? So double negation, I explained it last week. I said it's like you have your light is on, right? Your light is on here. Then you complement it by switching it off. So this is basically just one complement. Then you complement it again. Complement, you invert it, right? You use an inverter. You complement it again. So it's going to switch the light back on. You understand? So do you see that this is just a waste of energy? Waste of time and waste of energy, this double complement. So double complement is called double negation, right? Double negation. All right. So before we continue with that, please, so here I don't have those names that I just mentioned. Please write them here. Write them there. And these examples here as well. But I wanted to mention this. You see these associative laws, this absorption, commutative, but you guys don't really get this far. But there's that as well. Then obviously Boolean algebra. Then there's also absorption, right? So, but everything is here. Everything is really here. You can see for yourself. Okay, great stuff. So let's go back to our problem. Let's solve it quickly. So here they are saying, let's start with the easy ones. Easy one, AA, we know this is double negation. The answer is A, right? Then A or A, is this idempotent law? The answer is NA, right? So here we have something. We have A, D naught, A, B, D. So let's try to solve this one and see what we come up with. A, D, A, B, D. Okay. D is complemented. So what can we do here? So here we see that A is basically the common factor. We can take A out, but now if we take A out, we're going to have D naught. We're going to have D naught plus BD, right? plus BD plus BD. Then we are done. We can't do anything. Anyone else with something here? Anyone else? I see a small trick, but please say something if you can see something here, because I'm saying the one that's naked to the eye is basically just taking an A. For example, A, then you have D, right? Then you're going to have B, D, right? And then remember this D, it's complemented, right? But now when you're here, you are done. Do you understand? So it can be this, it can be like this there. So there's a trick to it. There's a trick. Okay, let's do number D first while we're still thinking about that one. This one is straightforward as well, number D. Let's do number D. So number D, for example, we have A, C, A, B, C, right? So it's C naught and C naught here, and then C naught. So our common factor is basically AC naught, right? Then we're going to have 1 plus A. We know 1 plus A is it's a 0. Sorry, it's a 1. A plus 1, it's a 1. So we know that. So here, so we're just going to multiply that by a 1, then it's going to fall away. So here we're going to take AC naught as our common factor, right? Because it's in this term and in this term. Open bracket. So this will be 1 plus AC naught multiplied by B, right? So we know 1 plus B. So this is how you solve it, right? So the moment you take out this, you need to write the rule name, right? Let's put it there, distributive. So everything that has to do with brackets, factorizing and multiplying out brackets is the distributive law, right? Then again, we have this law now, 1 plus B, right? 1 plus B, 1 plus B, it's A plus 1. So it's this one, it's the annulment law, right? So here for this 1 plus B, I saw at one other memo that they also said this. They said, because you need to give an explanation, right? So now they just put A plus 1 is equals to 1, right? So now you can also do this. A plus 1 is equals to 1. So I saw this in your memo. So it means it is allowed. So, or you can just mention the law name, which is annulment law, right? Annulment law. So what's happening now? This means that we have A plus 1 is a 1, so B plus 1 will definitely be a 1, right? Then our answer, then this is where you put your rule, right? Annulment law. Then our answer will be AC. So this is simplified. AC, right? So now we back to this one, guys. We back to this one. I believe with this one, let's see. We need to have something like this. We need to create a fake B, for example. Then we will have D naught plus D, which will give us a 1. So we need to leave this somehow. We need to take out this somehow. Let me just see if someone saw something. Okay. No one. All right. Okay. So let's try that. Let's try that. There was one that we did that was like that. We had to use this. You see, for example, we know that B ended with a B is equals to A. You see, we had to use something like that. So let's erase here. Okay. So here we have ABD. Yeah, ABD, and then here we have AD naught. So if we put a B, so we can't put a B. If we put whatever we put must give us a 0. Must give us a 0. So we have an A, we have this A. B, I think our thing is here. B and B, it's a 1. Yeah, we need something that can give us a 1. But ended, don't we have a 1 ended here? A and A, it's an A. A. Okay, no, A and not A. It's a 0. Maybe this. No. A, B. Okay, D not. D not. Oh, guys, here it is. All right, I see it now. Okay, perfect. So, because of this law, right? So what we're going to do is that we're going to take out D not or with a D, right? Yeah, that's why I was so surprised. How can it be so difficult? So we have D. We want to leave this in the bracket, right? So we're going to take out A. Okay, but we can only take out A. Then we're going to have D naught. We're going to have D naught. And then we're going to OR it with A is already out. We have B. Then we have D, right? We have, yeah, D. So we want to take this B out here. So we need to create a fake B. Then we're going to have D naught and then D. So how can we do that? So we know that if we say we can have the value 1 here. So we can have the value 1 just so that this can have a B so that we can take this B out, right? So we can say A, then creating our own B. How can we create that B? It should be a 1. Now we can't say B1 because it's gonna be inclusive. It's gonna be there. Okay, no, yeah, this is a challenging one. Anyone, guys? Does anyone see anything here? Yes, Nolitabo.
Hi, sir.
Mm-hmm.
I did the another way.
Yeah.
So for like like it's AD, not D,
Mm-hmm.
plus ABD. So I introduced the B on AD
Yes,
since we
this
already
side.
have yes on
Mm-hmm.
that side. Then will be plus ABD.
But now
Then
if you introduce just a B, yes, I'm thinking we need to introduce a B here. But if we just do it like this value, it changes this. This value of B, it must be B, it must be 1. This value of B. Are you with me? Or
yes,
0?
yes, yes.
Okay. But continue and then okay, so you just did this and then here it was ABD.
ABD. Then I factored out AB. Then it
Mhm.
will be not D plus D.
Then it's gonna give you this one here. Mhm.
Yes, then it's going to be AB times 1 because you're going to use the independent law, which is
Mhm.
A plus not A is equals to 1. And the answer will be AB. That's how I did it.
Okay, but it's gonna kill us here. This B, if we put the B here, we need to put it this side as well. Do you remember mathematics?
Oh, yeah, yeah, yeah,
Mari, we have done something like this. It is here. We did it in one of the classes. You see here it is AA. It's AA. But let's see what we did here. So here, for example, it was a A. We said AA gives us a A. But the thing is, we don't have a B. Are you with me? We don't have a B. We're trying to introduce the B. And then AB, okay, AA plus AB plus AB naught. This is the absorption law. Let's see. Let's see this law first. A plus AB. Maybe if we work back here, we had an A. You see, we haven't had one where here we don't have the B. We're trying to introduce the B.
Okay.
You get me? But you see here, we had an A. This is this law, right? But we had an A. There we don't have this B that I'm talking about. So we can have a B if that BB, you see, there it was AA. It gave us an A. So we can use this one because of that A. But we can use maybe if it was gonna give us a 1. Do you understand?
Yeah, I do. I
So
do.
so the only one is this one. Okay, guys, that one is a bit challenging. I'll play around with it, but I honestly don't see I know it's dependent on this D naught, odd with a D, but before that, but what is B? If we say B, but we are absent here. If we put a B this side and then we put a B this side, we're still in trouble. Okay, if we say, just thinking now for the last time, if we say we need something here. Okay, no, let's leave this one. But anyway, I will definitely look at this one. Don't worry about it. Look at it. So anyway, Boolean algebra, you need to know these 12 laws, right? And then after those 12 laws, you can write the reasons like this, or you can write it like this, like I showed you here with the law itself, right? Okay, let's see what else was there that talks about maybe in the same. Okay, there's no break the line, change the sign here. Okay, then this normally goes with your De Morgan's theorem, right? De Morgan's theorem will be, we know that it's break the line, change the sign. But they will just give you, it will basically just say that you break this line in half, you change this sign. So this is going to be complemented. Then you change this sign into an OR gate, then you complement this one, right? Here is one of the examples. I don't want to do a long one. So for example, this one, okay. So De Morgan's theorem, it says that we're gonna break this line in half, then we're going to change this sign, right? So here we will definitely have A plus B, A plus B, A or B with our brackets. Then we're going to change this sign in the middle to A and the gate. Then we're going to have CD. CD, right? So we're going to split this big line into half now. So we break the line, then we change the sign, right? Okay, so now we're going, this is basically divide and conquer. So now we're going to focus on this one. So on this one, we will have the A here. So we're going to break this line into half. Then we're going to change the sign, not B. Split this one. Then we have this here, break the line, change the sign. So we're going to have the C or B. So we broke that line. Then we change the sign, right? Oh, guys. Okay, that's a C. Pretend it's a C, right? Okay, so here we have double negation. You remember double negation? Yeah, so you're going to write it on the side. This is double negation. So you're gonna have a, then you're going to have a B naught, B naught. Then you're going to have a C, C naught, C naught. Then you're going to OR it with a D naught, D naught, right? So this is basically what you just say. Then from here, let's see, you can't factorize any further. Let's see, what was our final answer there? A, B, C naught, A, yeah, B, C naught. So you stop when you can't break the line anymore. So you can't break the line, you can't factorize, you can't simplify anymore, right? So it's basically here, we just put a bracket there, right? Understandable? Okay, guys, we are done with this one. Let me stop this one.